Yeah.
Like the numbers? Are you playing with numbers?
Yeah,
Okay, good. How about you?
transferred to champion.
Okay, all right.
I moved from Mexico.
Let's get going on this.
So she's also like, I think it's like
Everybody ready to talk about this? You ready? Ready? Okay, so I gave you this because I figured it was going to cause a problem for a few reasons. First, because I used y instead of x, so that alone makes people not happy. But the 3 in front, right? So, like I said at the beginning of class, there is an expectation that you, at some point in your life, knew how to do this, right? And I'm going to have to throw you the lifeline now to kind of give you something that you can take forward with you. That's, I guess, to supplement you going to the lab or getting help and doing more practice with this, all right? So let's start with the numerator. Let's start with the top one. 3y squared minus y minus 2. All right, we're going to try and factor that. And what that means is we're going to try and break it down into 2 factors. And the reason I'm using this idea and this method is because I see 3 terms, and the power starts with squared and then it goes away. It goes to 1 and then it goes away. So whenever I see that, it's called a trinomial, a quadratic trinomial, and therefore I'm going to try this method, all right? Somehow make it something done something. Now, the method I'm going to show you is a modified AC method, all right? So those of you who have learned something called the AC method, this is like a modified version of it. Okay. And here's how it goes. So what I'm going to do is I'm going to take the number in front, right here, 3. I'm going to multiply it times the number in the back, and that's -2. When I multiply those 2 numbers, I get -6, right? And there's a cute little thing, and I already told you I'm not all about cute stuff, but this kind of works. Draw an X, right? And that -6 is going to go here. And then the bottom of this X, what you're going to do is you're going to put the number that's in front of the middle term. So this leading coefficient right there, -1, you're going to put right there. They call this the AC method because when you write what's called the general quadratic expression, like this, the number in front of x squared is called a, and the number by itself at the back is called c. And the first step of this method is to multiply the a times the c, and that's why we call it the AC method, right? I didn't make up that name, that's just what it's called, all right? So we got these 2 numbers. Everyone understand where they come from?
Yeah.
Now your job is to look at these 2 numbers, and you have to come up with this, whether it be out of your mind or on a calculator. You have to come up with 2 numbers that multiply to be this, but add up to be this. Okay? So you think about it, and you have to keep in mind what the signs of things are. So I need 2 things that multiply to be -6. Let me list out all the different ways I can get -6 from 2 numbers. I could do 6 times -1. I could do -6 times +1. I could do 3 times -2, and I could do -3 times +2. And those are the only ways I can ever get -6 from 2 numbers, as long as we're talking about whole numbers, right? These are nice numbers. There's an infinite number of ways to get -6 if you include fractions and things like that. But if we're just talking about whole numbers, this is it. You all agree?
Yep.
You don't think of another way to get it?
Yeah.
Yes. With whole numbers? What? So can
I'm
you think
gonna
of
go
another way to
ahead,
get
I'm gonna go ahead and
-6?
take a wild guess and say the 4th one.
No, I'm saying, can you think of any other 2 numbers that I can multiply together to get -6?
Oh, I can't.
Yeah, this is it, right?
Yeah, this
We've
is it.
exhausted the list.
I'm sorry.
Sorry. So now what we need to do is see which group in this list multiply to be -6, but add up to be -1, and that would be the 2 on the bottom right here, right? Those 2 multiply to be -6, and if you add those 2 numbers, you get -1. So what we do is we put those numbers here. And it actually doesn't matter if you did it the other way around. You could have put 2 here and -3 here. This is the method will work, right? Everyone got that? Yes? Okay, now what we do here, and this is the part that I'm saying, this is a modified AC method, all right? Because there's different versions of this. This is my favorite version of it. So what I'm going to do is I'm going to look at what the variable was here, right? Y. I'm going to write it down here and here, and I'm going to leave a space in front of both of them, right? A little bit of a space on purpose, like that. And then behind this, or next to this y, I'm going to put the first number, minus 3. And over here, I'm going to put, because that's a positive 2, I'm going to put plus 2. I'm not done. I'm not done. Any questions on what I did though? Space variable, the first number, space variable, the second number. Yes?
Yep.
Okay.
All right, last step of the AC method is that you're going to take the 3 that's in front here. And I should pause real quick for a second. Do you all see right now this is not right?
Yep.
Like if you tried to multiply this out, what would be the first thing you get?
Y squared.
Y squared. And we have what? 3y squared. So there's more that we have to do to get the 3y squared to appear. So here's what we do. We take the 3 that's right here, that's a positive 3, and we are going to divide both of these by 3. Okay?
Why would we do that?
Okay, so this is where you, if you want to know why, okay, if you want to know why, that's an office hours, let's sit down and I will derive the method for you and show you why it works.
Okay.
This is more of, again, I'm throwing you something to help you so that you can do something like this, right?
Okay, yeah.
So that step right there doesn't make a lot of sense, but trust that it works.
You'll put the 3 on the right side, right?
Yeah, so now what you do, you put the 3 underneath, you reduce the fractions if you can. So 3 over 3 is 1, right? So this becomes, let me erase this down here. This becomes y minus 1. And then over here, does this reduce?
No.
No, not.
No, it doesn't reduce. If it doesn't reduce, or I should say, even if it did reduce, if you're left with a fraction, which we are, we're left with a fraction. This is a fraction.
Okay.
You take the denominator and you swing it up in front of the y, if you're left with a fraction. Okay, so now our next line would be 3y, what, plus that swung up here, and we're left with just the 2. And that is the factorization. And again, don't ask me why. It works, all right? I'm not saying don't ask me why ever. I'm saying I'm not going to explain it in this class,
Okay.
all right? That's the answer. Now, you might have gotten it the other way around. You could have had it this way. That's fine. Multiplication can switch. But can we check? Hold on. Can we check to just see that this works? Y times 3y? 3y squared. Okay. Y times positive 2
Plus 2y.
plus 2y. Negative 1 times 3y.
Negative 2y.
Negative 3y. And finally, negative 2, right? Minus 2. And we can combine these two together and get negative y. And so you have 3y squared minus y minus 2, which is the original expression, right? Okay, that's the modified AC method. What are the pros and cons to this? Well, the pros are that it works, right? The cons is it takes some time. And so for those of you who are already at the point of like guess and check and just doing it mentally, that's going to be a huge advantage to you when you get to a class like calculus, because calculus, the thing that, like I told you, the algebra is what holds students back, and time on a test, right? When I give my calculus test, I'm not only testing their knowledge, I'm testing their efficiency, right? So if it takes you 8 hours to get to the problem, that's an issue in Cal 1. You need to be able to get to the answer, quickly. So even though this AC method is going to kind of help us move forward, it's kind of like the box method you were talking about earlier. Does it work? Yes. Is it helpful when you're learning it? Yes. Do you want to do that the rest of the time? No. AC method is something that you don't want to have to hold on to forever. So you do want to get to a point where you're doing the guess and check. So I want to do this same problem, but I want to do it guess and check, just to kind of show you. And there's no way we can do guess and check in here, give it any true, what am I trying to say? Guess and check just takes a long time to get good at, all right? So the way I would do this if I were doing guess and check is this. I would say to myself, okay, I need a 3y squared, right? So the only way to get 3 is, well, probably 3y and y, right? That would get me 3y squared. Now, I also need a negative 2 at the back, right? Negative 2, so I can put how can I get negative 2? I can do negative 2 here, and I can do plus 1 here, right? I can do that. Do you all agree the last multiplication would give you negative 2? The question is, does the middle work? So here to here gives me 3y squared. Here to here gives me the minus 2. So the question is, will this happen? Does it or not?
No.
Well, if I do FOIL, that works, right? So I'm good with that. Here to here would give me what? Negative 6y, and then what would this give me? Plus y. Negative 6y plus y would be negative 5y, and that's not what I want, right? So that doesn't work. So then I try again. 3y, y. This time, instead of putting negative 2 here, maybe I put the negative 2 here and the plus 1 here. And now I try that. You all see that that still gives me the same first and last terms? But does the middle work? That works. What's this? 3y. And what's this? Minus 2y. That's y, not, what do I need? Negative y. Shit. So the signs are backwards. So I put this plus and I put that minus. Now it works. That's guess and check. And the more you do that, the better you get at it. So you want to work towards that maybe, but don't let it bog you down this semester. I mean, you just want to, you got this, you got pre-cal. By the time you get to calculus, you want to be doing this pretty quickly. All right. We got 20 minutes still. All right, how about this bottom one? Let's do the bottom one, all right? Should I let you try that? Because a lot of you got hung up on the bottom one. Do you want me to let you try that with the AC method or guess and check? Let you try it again? How many of you still have not done the bottom? Still have not done the bottom? Okay. How many of you have finished the bottom now? Okay. Let's just write it down. Let's move on to the next problem. Let's for those of you who haven't done the bottom, you can do that on your own. Let me just write this down. This was 3y, y, what was it again?
Plus 2.
Plus 2 minus 1. And on the bottom, if you do that one, you should get 3y, y. Who has it?
They're both pluses.
Plus?
Plus 2 and plus 1.
Plus 2 plus 1. Let's see, I can check that quickly. Yes, that works. So I'm not showing that step. Now, these two go away, right? And remember, there's a little asterisk here now. There's a little asterisk here. This will be a good one. I'll give a 2-point bonus on your first exam. Somebody who can tell me what this asterisk is. You got to get it right though. Okay. Think about it first. What is that asterisk saying? When I cancel these, what is the asterisk? Anyone want to try?
Oh, that's.
Who wants to try? Okay, I've got 2 people, so I'll give those 2 chances. Start here.
So as long as y does not equal negative 2 over 3.
Negative 2/3. Very good. As long as y is not negative 2/3. So the idea here is, what would make this 0, right? What would make that 0? Well, you have to either solve that mentally or write it down. Thing is, you cannot cancel this if this is 0, right? So take that, set it equal to 0, move the 2 to the other side, and then divide by 3. If you try and plug 2/3 in right here for y, you're going to get 0 on the bottom. I'm sorry, negative 2/3. Plug negative 2/3 in right there, you're going to get 0, and that would be a problem. So your asterisk, very good. This is okay. It's okay to cancel so long as you promise me that y is never negative 2/3. I'm not going to test you all on that. That's why it's a bonus. All right, let's look at the next problem we want to be able to do, and I'm starting to run a little short on time here, but it's okay. Okay, so we're going to do, I'm going to do 26 first. So x squared plus x plus 6 over x minus 6, thank you. Then we have x squared plus 4x minus 5 times, and then we have x squared minus 25 over x squared plus 2x minus 15. So we're going to do this problem. we're still in the first week, so I want to have a quick discussion before we get into this. And I think I'm going to mute myself. Yeah, I better mute myself. It's 2023. I got to be careful. All right. So when we're sitting here and we're learning all this, right? I know that some of you might sit there and be like, you know, really, why do I need to know all of this, right? Like, why do I really need to know all of this? Like, if you become an engineer, do you think you're ever going to be doing this? Probably not. If I was your boss, right, and I hired you from an engineering firm, I would ask you to go to the computer to do this work because I trust the computer to not make human mistakes, right? So why are we doing all of this? Like, what's the point of all of this? Learning all this stuff. In my opinion, there are only certain degrees that you need to have the formal education for. There are only certain life paths, engineering, science, medical, all that, you have to go get a degree. You need the formal education for it. But at the end of the day, it's not about the algebra and the calculus, it's about being a problem solver. That's what it's about. Are you an independent learner? Are you a problem solver? Are you the type of person that when you're faced with something difficult, you curl up in the fetal position and give up? Or are you the type of person who can't really go to bed until you figure it out? You know, people are different, right? People have different interests. So this is really testing, you know, can you learn things that require lots of steps without making mistakes? All this stuff, very analytical thinking, right? So as you're sitting there, you know, like, why, you know, if you ever question why we're doing this, there's a big picture to this, right? There's a big picture. My brother is an engineer, okay, and he, his job interview for his position, okay, would y'all like to hear the questions they asked him? I'll give you a couple of questions they asked him, all right? So the first question they asked him for his interview was this. So pay attention, because every word I say is important in this question. So imagine you're getting hired, right? You have a master's degree in engineering, right? Electrical engineering. You have a master's degree. You sit down in front of this committee of people to get an interview for a job, and they ask you this, or they say to you this. 2 archaeologists walk by a cave. One of them goes into the cave, comes out a few minutes later, and tells his buddy, hey, I just found the perfectly preserved remains of the first human being ever. The question is, how did they know that they had found the first human being ever? That was a question. That's a job interview question. Not a calculus question, that is a thinking question, right? That is a critical thinking question. So I'll restate the problem. He only got the question one time, okay, but I'm going to restate it for you. 2 archaeologists walk by a cave. One of them goes inside, comes back a few minutes later, tells the other archaeologist, hey, I just found the first human being ever. How did he know he had found the first human being ever? So don't give me an answer. If you have an answer, you can raise your hand. I'm just curious to see if anybody, and you're not allowed to ask questions, all right? I mean, you're in a job interview. You can't be like, well, answer the question, right? So, were you raising your hand or do you have a question? I'll let you ask questions, but.
I was going to say he was BS.
Pardon?
He was like bullshitting.
Oh, he's bullshitting?
Yeah.
Okay. All right, well, this is not a job interview, so you can say that, that's fine. Right? Anybody have an answer? You want to go for it? Okay, what?
How would you walk into a cave that's on the surface or slightly below and find something that's allegedly very, very old? Like older, like thousands of years in the dirt versus, and you're just right there.
Oh, how did,
Yeah,
so you're questioning the question.
Basically, how deep would you have had to go in that cave to just come right back out? Because that would have to be very deep for that to actually work.
So, I hear what you're saying. You're skeptical about the question, right? The question is skeptical whether or not they could have found.
How you would have possibly found it in that short amount of time just walking in the rock.
So you're thinking about it too literally. okay, the bigger question is the words I used, right? You have to pay attention to the words I used, right? Two archaeologists walk by a cave. You have an answer? Hold on. Don't say anything yet. I'll let you have your answer. Two archaeologists walk by a cave. One of them goes in. A few minutes later comes out, says they found the perfectly preserved remains of the first human ever. How did they know they had found the first human? So, do you have a question? Or do you have an answer? No?
I'm not an archaeologist.
Yes.
Yes.
Oh, go for it. Oh,
Yeah, that's the answer.
oh, I'm not an archaeologist. Okay.
We know the craft.
Okay. Yes?
I just take a long guess and say that it depends on where the, like what environment they're in.
Yeah.
Like if they're on like continental, like Africa, or.
So do you have an answer?
No.
You don't have an answer. I'll get to you. Do you have an answer?
Yeah.
Carbon date?
Carbon decay.
Carbon decay? Okay. It came out within a few minutes, so I'm not sure
I mean, yeah.
if we had time for that. Yes? And even if you dated it back, like, how do we know it's the first human? You know what I mean?
I would just say, show me the proof.
Show me the proof? Oh, okay.
Wait, proof.
I have a question.
Okay, you have a question?
You can go ahead.
I want to ask, like, you said that you had a mechanical engineering degree.
Electrical engineer.
Oh,
Yeah. Okay, did you have a question?
Can you reset the question?
I'll reset the question, last time.
Okay.
Two archaeologists walk by a cave, one of them goes inside, a few minutes later comes out, says, I found the perfectly preserved remains of the first human being ever. How did they know they had found the first human being ever? Do you have any answer?
Isn't it like how old the rock is? You can tell how long it's been there.
Okay, how would you know that that's the first human though? Because like, do we know the first human, like when it happened? Like we can't, so even if you knew how old the rocks were, how would you know that there wasn't a human before that? Yes?
They did.
They didn't?
Yeah.
They didn't what?
They didn't know.
Okay, are y'all ready for it?
Both
Are
of
y'all
them
ready for
didn't
the
know.
answer?
Yeah.
You're ready, you're not ready for it?
Is it? Does that
Look,
happen?
I mean, at this time, he had to have given them an answer. He didn't have, 10 minutes to think about this. You had to answer the question, right?
Wait, can you tell us what he said?
Yeah, I'm gonna tell you. I'm gonna tell you, because he gave the answer.
Okay.
He gave the right answer. Okay, you ready?
Ready?
Okay. Do you want me to explain the thinking first, or just give you the answer?
Answer first.
Answer
Answer first and then
Okay,
think.
okay, so how did he know he had found the first human? Because it didn't have a belly button. Okay, so listen to the words. He found perfectly preserved remains of the first human. Perfectly preserved remains means that the body was completely intact, right? Which means every aspect of it could be identified. And if you are the first human, you weren't born. If you weren't born, then you don't have an umbilical cord.
Oh.
Right?
Yeah.
That's the answer they wanted.
That's
You got it.
the answer.
So, now, I mean, imagine your job interview. That has nothing to do with your electrical engineering, right? In that split second, he had to process everything and give an answer, right? And he's now one of the directors of that company. But you know what I mean? Like, he started there answering phones, doing tech support for that company, like, and then moved his way up. So, I'm just trying to kind of like help you take a step back from everything, because as we sit here and we do all this mechanical stuff and you get frustrated with the math, you have to keep an eye on the bigger thing, which is critical thinking, problem solving, persistence, right? These are things, the more you do it, the more you become the type of person who can answer a question like that without having to think too much about it. It's just, boom, it's there. Does that make sense to you all?
Yeah.
Take what you want from that, but I think it's an important lesson. Then there were some other questions that were, they were more analytical, like, I won't get into those, but that was their opening question. And like, anyone who got that wrong, they just said, okay, not you, we're moving on to the next person.
It's partially funky because it depends on what you think happened with the first human, because a lot of religious people would say that.
Well,
And
some
then you have
people,
a lot
if you're
of-
religious, you might say that, they were missing a rib or something like that, right?
And then you have a lot of scientists that would say they would have the belly button, but they changed from something else.
So as you're sitting there, right, in the interview, you have to think about what these engineers want you to answer, right? Now, if you're applying for, to become the leader of some religious escapade or something, then maybe your answer is like, they're missing a rib or whatever your belief is, right? But you're sitting around a bunch of engineers who think very analytically, right? So the answer is no belly button. I mean, who's going to contest that answer? I mean, how do you contest that? How do you contest that?
The other way to
Would
contest that-
the first person have a belly, even if it's religious, would the first
the other way
person
to
have a
contest
belly
it
button?
Would be saying that it was evolution, saying we
Yeah.
evolved from an ape.
Okay, but if the first person was put here by some higher being, would they have a belly button? I mean, I'm just saying it's debatable. All right, we're not getting into it. You got the job. You got the job. Yeah. So,
Wait, but did he answer that?
pardon?
Did your brother answer
Yes,
that?
he did.
Oh, okay.
Yes. All right, so this problem here, right? Yeah, let's do it. I mean, this would be a good time to wrap up, but let's just do this problem real quick. This is problem number 26. So your homework tonight, just to be clear, I'll put it up here. I expect that you'll do all of the homework from R4, and for R7, we're doing number 26. So for R7, only number 15. We went pretty slow today, so it's okay. It's okay. It's going to be the way it is. So your quiz will come from the problems from R4, or I could give you number 15 from R7. Right? That's what I promised you. So let's do this problem. So this problem here, you're trying to multiply these rational expressions together, right? You're multiplying these rational expressions together, and you're going to have to try and factor all of these. There's 4 things to factor here. You got to factor this, you got to factor this, you got to factor this, and then this one right here I'll circle in red. This one right here is a special one because these 3 are all done using like AC method or guess and check because they all look like they're all trinomials, 3 terms. This one is 2 terms, and you have to recognize that as that special one called the difference of squares. I'm just going to put difference of squares. So why don't you take the remainder of the time, okay, which is only 6 minutes, to see how far you can get with this. And I'll put the work up here. You just work, and then see if you can get to what I get to. And then when you're done, you're free to go. How about we do that? And that way, if you're good and you're happy and you can do this, you can move on with your day. But if you need me to help with something, I can. All right? Any questions? All right, I'm going to just... Should be it. There's nothing more you can do with that.
I'll say maybe you can distribute it. Oh,
They're not off by a sign. Yeah, they're thinking up for these 2.
and the.
And the problem is that the X's here are both positive. The only thing that's off is this. You need them to both be on. So this would be it. Okay, if you got that, again, do your homework. If you need to, hit the tutoring lab, JH36T or 308 for factoring review. They have worksheets over there that can help you with factoring, right? Come by my office. Otherwise, have a great weekend. There's a holiday on Monday, right? So that doesn't affect us at all, but if you have a Monday, Wednesday class, there's no classes on Monday.
Wait, oh.
Monday, yeah, so Labor Day. No one will be here. You have a good weekend.